Your Kubernetes pod is restarting again and again, crash loop back off, and no matter what you try, your application refuses to stay alive. And here's the scary part. This is exactly what happens in real companies. Everything looks green, deployment succeeds, no warnings, and still the container dies every 10 seconds. Before we start breaking and fixing Kubernetes, if you want more incident-based Kubernetes videos, not boring theory, hit like right now so YouTube knows this is the content you actually want. Alright, let's crash our first deployment. Welcome to episode 1 of my Kubernetes Simulation Series. This is not a typical Kubernetes course. I'm not going to show you pods, deployments, services from slides. I'm going to show you real production outages. And we'll debug them like DevOps engineers do it on job. Every episode is a real incident, real logs, real failures, real debugging. Let's start by deploying a small Flask application that's about to completely misbehave. Alright, let's jump into the demo. I already built a Docker image and applied the Kubernetes manifest. Let's check the pod status now. For that, I am going to run kubectl get pods. Press enter. And as expected, crash loop back off. Kubernetes tried to run our container. It died instantly. And now it's stuck in a restart loop. What exactly is crash loop back off? The application starts, it crashes. Kubernetes tries to restart it, it crashes again. Kubernetes backs off and keeps retrying until you fix the root cause. This is the number one incident DevOps engineers face. If you see, previously we had restart 6 times. Now I can see the number 7. Any production debugging, always describe the pod. I'm going to run this command kubectl describe pod and the pod name. Press enter. You can see restart increasing, back off increasing, container terminated with exit code 1. But notice something, there's no clear error message. Describe rarely tells you why the application crashed. It only tells you that it did crash. Logs never lie. If your pod is crash looping, this is always your next step. kubectl, logs, and the pod name. Press enter. Oh wow! There it is. DB hots not found. Wait. What is DB hots here? That's not even a real environment variable. This looks like a classic typo error. Let's open the application code and check what's going on inside. And there it is. DB hots. The application is trying to load an environment variable DB hots, not DB host. Let's try to fix that real quick. DB host, and also I would like to update it here as well. DB host. One single wrong letter and your entire application refuses to start. This is the type of mistake that causes hours of downtime in real companies because Kubernetes won't tell you Bro, your Python code has a typo. It will just restart the pod forever. Now let's check what Kubernetes is actually passing to the container. I'm going to open my deployment.yaml file and let's scroll down a bit. Here I can see db host. It's perfectly correct. So Kubernetes is passing the correct variable here. But the application expects db hots. This mismatch is the root cause. Kubernetes is not at fault here. The application is misconfigured and people will try to blame Kubernetes is difficult. This is why DevOps engineers always cross-check environment variables in both places, the code and the deployment.yaml file. Now let's try to rebuild that image. Before doing that, I would like to update our image name here. Instead of latest, I would like to give it as version 1. And also we are going to rebuild the image using the exact v1 version. Never use latest in production environments. You will be in a lot of big trouble. So rebuilding local images are immediately visible to Kubernetes. I'm going to run this command real quick. Press enter. Now we are going to delete the old deployment completely because this will clear the old pod and forces Kubernetes to pull the fresh image when we reapply. Press enter. Followed by, I would like to say kubectl apply -f deployment.yaml file. Press enter. You see the new deployment got created successfully. Now let's try to run kubectl get pods. Press enter. There we go. The pod is finally running. No more crash loop back off. No more restart. A single letter typo caused the entire outage and Kubernetes simply exposed the problem. Here's the important lesson. Crash loop back off is almost never caused by Kubernetes. It's almost always caused by bad environment variables, missing dependencies, typos, wrong image tags, bad startup commands, unhandled exceptions. Kubernetes is just the messenger. The real problem is almost always inside the container. And that's episode 1 of Kubernetes Simulation Series. In episode 2, we are moving to a subtle production outage, a service that refuses to send traffic because of one small selector mismatch. This one confuses even senior engineers. Comment episode 2 if you want that episode next and I'll drop it early. Like the video, subscribe for more real world DevOps and Kubernetes incidents. Thank you for watching and see you in the next video.